This is question 10 of the Natural Sciences Admissions Assessment specimen paper. And in this question we have three variables, x, y and z, which are related to each other in different ways. So x is directly proportional to z squared, y is inversely proportional to z cubed, and we want to know the relationship between x and y. There's a few different ways we could approach this problem, and I'm going to show you two. The first is slightly more long-winded, but might be a bit clearer if you've not seen a problem like this before. And the second is a lot slicker and a lot faster, so would be a great approach to use in an exam when you're under time constraints. So the first thing we're going to do is write out these two bits of information we know, I and II, in slightly more mathematical terms. So x is directly proportional to the square of z, so x equals some multiple of z squared. And similarly, y is equal to n over z cubed, so it's inversely proportional, which is where the division comes in. So now what we're going to do is rearrange this first one so that we get z squared. So we have z squared is equal to x over m. And now we're going to substitute this first one here into what we have for y here. So let's do that now. So we say y is equal to n over z cubed. Well, z cubed is just this square rooted and then cubed, so to the power of 3 over 2. So we get something which looks like this. Now, if we rearrange this, we get z is equal to some constant which is coming from n's and m's, but we don't really care about the constant, so we're just going to call it k1, divided by x to the 3 over 2. And so we can square the whole thing to get that y squared is equal to k2, which is a different constant. Again, we don't really care about the constant, divided by x cubed. And so we find that y squared is inversely proportional to x cubed. So x cubed is inversely proportional to y squared, and our answer is D. So now it's time for the slitter approach. I've rewritten out our two conditions here. So we have x is proportional to z squared and y is inversely proportional to z cubed. So what we're going to do is get both of these in terms of a common power of z. And the smallest one we can do is z to the power of 6. So let's do that now. So if we cube this equation, we get x cubed is equal to m cubed z to the 6. And so we can do similar for this, so we can square this one to get that y squared is equal to n squared over z to the 6. Now all we need to do is eliminate the z to the 6. So we can substitute in z to the 6. If we rearrange this, we get z to the 6 is equal to n squared over y squared comes down here. So we'll write this out, x cubed is equal to m cubed, z to the 6 we've taken from here, and we get something which looks like this. Remember that we don't really mind about the constants, so the m cubed, n squared, we don't really mind about that. So we get that x cubed is inversely proportional to y squared. So we get the same answer of D. So this way is a lot quicker, as you can see. So it's a good idea to have a look at both of these ways and understand why this way is so much quicker. So when we get a question like this, we want to straight away try to eliminate the z, or in this case, the z to the 6, as such.